Hey everyone, welcome to Run2Go channel. Managing complex data in Unity is a total productivity killer. That's why I built OptiTerra. Even in Unity 6.3, the default HDRP terrain shaders are limited. No tessellation support, only parallax occlusion mapping. On my research shows that parallax occlusion mapping is much heavier than tessellation on the Unity terrain system, which I'll show in this benchmark. Then there's the texture channel packing nightmare. It's exhausting to Alt-Tab to external apps just to repack a channel. Plus, most terrain layers don't even need a metallic map, including it only drags down your performance. In this video, I'll show you how OptiTerra simplifies this mess. We'll use the OptiTerra Terrain Manager components. It's a complex system, but highly organized so you won't get confused managing your data, all automated inside Unity. Let's get started. First, let's talk compatibility. I'm currently using Unity 6.0, but OptiTerra supports up to the latest 6.3. As you can see, I've already prepared a project with the OptiTerra asset installed. In the scene, I have a standard terrain, but it's still using the default Unity shader, which, as we discussed, isn't ideal for performance. Now, the first step, select the game object that has your terrain component. All you need to do is add a new component called R2G OptiTerra Manager. Once you add it, you'll notice the OptiTerra automatically create a folder called OptiTerra Data in Assets folder for save any modification about terrain data, and also the terrain will immediately turn blank. Please don't panic. This happens because we haven't assigned any textures to our custom shader yet. It's perfectly normal, and we're going to fix that right now. After that, take a look at the OptiTerra component. You'll see a Convert to OptiTerra button and a Layers tab that is already synced with your existing Unity terrain layers. The great thing is you can add, remove, or modify these layers directly from here. You'll also notice the channel packing options. I've included 4 different models to fit any workflow: Mask HDRP, URP, ARM/ORM, and a custom other preset. We'll dive deeper into those packing models in a moment. But for now, since we don't need to change our existing layers, let's just go ahead and hit that Convert to OptiTerra button. Once you click it, OptiTerra will process your data and pack it into 2 specific channel schemes. Shortly after, a pop-up window will appear to configure your texture 2D array settings. You'll see 2 main categories: CH, which stands for color and height, and NOS for normal, occlusion, and smoothness. Here you can define the resolution for each array. Pro tip from my experience, I usually downscale the resolution for the CH array. Since it only stores color and height data, the visual difference is often negligible, but it significantly boosts your performance and saves memory. Once you've tweaked the settings to your liking, just hit that Generate Texture 2D Array button. And boom! Just like that, your shader is ready and your textures are fully generated. You have successfully converted your data from Unity default to the OptiTerra shader. If you want to inspect the results, you can find everything in the OptiTerra data folder. Or, for even quicker access, just click on the material slot inside the R2G OptiTerra Manager. It will automatically highlight the material being used and all its associated data in your project window. Now, looking back at the manager, you'll notice it has updated to display all the essential information about your terrain. This is your command center. From here, you can monitor performance stats, manage your layers, and see exactly which features are currently active. Everything is neatly tracked in one place, so you're always in control of your environment's optimization. Now, let's dive deeper into the R2G OptiTerra Manager. We'll start with the general settings, which consist of 3 main options: sampling method, basemap start fade, and basemap end fade distance. First, the sampling method, a crucial setting to decide on early. The default is fidelity mode. Here you have total freedom to customize settings per layer, including the tessellation factor and, most importantly, anti-tiling. While other assets only support global anti-tiling, OptiTerra gives you granular control for maximum visual quality. Alternatively, we have performance mode. You still get all the features, but tessellation and anti-tiling are applied globally. This offers the fastest optimization possible, making it the perfect choice for mobile devices or hardware where every millisecond counts. Second and third are the basemap distance settings. The start fade distance is where the shader begins to smoothly transition its quality for optimization. The end fade distance is the point where the terrain is fully rendered using a lightweight shader. The best part? These controls are automatically synced with the basemap distance in Unity's default terrain component, so you don't have to worry about manual alignment. This gives OptiTerra a huge advantage, providing a much smoother gradation between the main shader and the base map compared to other terrain assets that often have harsh, noticeable transitions. Now, let's look at a very specific part of the manager, the Performance tab. This tool lets you monitor exactly how your settings affect the rendering process. First, we have the Relative Performance Cost bar. This is a real-time indicator of how your custom shader compares to Unity's default terrain shader. Next is the bandwidth estimate, which shows you the data throughput in size per frame. If you're using tessellation, you'll see an efficiency breakdown here, helping you balance detail and speed. And finally, there's the VRAM usage. This tells you exactly how much video memory is being allocated for this specific shader setup. With all these metrics, you can fine-tune your terrain to be as beautiful as possible without killing your frame rate. Moving on to the Layers tab. This is where all the specific information for each layer in your shader is stored. Inside, you'll find two mini tabs, Layer Channel and Layer Settings. In the Layer Channel tab, you can view and organize how each terrain layer was structured before being packed into our two texture schemes. This tab is incredibly helpful when you need to add new terrain layers that use different texture channel standards. It gives you a clear overview and full control over your source data, ensuring everything is correctly assigned before it gets processed by the manager. Now let's see a practical demo on how to add a new terrain layer using textures from Polyheaven. Once you've picked your texture, make sure to download the diffuse ARM AO/roughness/metal, displacement and normal map in OpenGL format. I highly recommend using PNG for all of them. After downloading and extracting them into your Unity project, you need to configure the import settings correctly. This is crucial. Make sure the diffuse has sRGB enabled, while the others should have it disabled. Also, don't forget to set your normal map to texture type, normal. Getting these settings right ensures that OptiTerra processes your data with perfect accuracy. With your textures ready, simply click the Create New Layer button. A window will pop up where you can name your layer and choose its save location. Since our Polyheaven data is in the ARM format, set the mask type to ARM underscore or underscore ORM. If you're using textures from other sources, the Others mode has you covered. Now assign your textures to their respective slots. You can even pre-configure settings like anti-tiling or tessellation right here. Once you're satisfied, hit Create Terrain Layer. OptiTerra will automatically add it to your Unity terrain and the R2G Manager. One important note, whenever you make changes in the Layer Channel tab, whether you're reordering layers, adding or removing data, you must click Rebuild Texture Array. Afterwards, this ensures your texture array is updated with the latest data and everything renders correctly. Next is the Layer Setting tab. Unlike the previous tab, any changes you make here take effect immediately without needing to rebuild the texture array. The options here adapt to your sampling method. Since we're in fidelity mode, we have granular controls like anti-tiling, tessellation factor, amplitude, offset and base. We'll cover anti-tiling and tessellation in the Features tab, so let's focus on the height settings. Amplitude controls the height map range, stretching or shrinking it to your liking. Then we have offset and base, which work together. Offset determines how superior a layer is compared to others, while base is the lowest point of that layer's height map. For example, if you wanted to sink a layer deeper, just move the offset to a negative value relative to the base. This gives you perfect control over how layers blend and overlap. Let's step away from the layers for a moment and move to the Features tab. This is arguably the most fun part of this shader. At the time of this video, OptiTerra features 4 main pillars: height blend, tessellation, anti-tiling, and the rain effect. Let's break them down one by one. First up is height blend. This functions similarly to the standard Unity default shader when managing transitions between layers. However, I've designed it with a significant upgrade. You get extra control over blending positions through the offset and base settings we saw earlier in the Layers tab. This allows for much more natural and precise transitions where layers meet, giving you that high-end look with minimal effort. Next up is tessellation, a standout feature of OptiTerra. Unlike many other assets, our tessellation supports GPU instancing by default, giving you a massive performance head start. Let's look at the settings. LOD level controls the height map sampling sharpness. Lower values mean sharper details but higher performance cost. If you're in performance mode, this is where you'll set your maximum tessellation factor. We also have the amplitude multiplier, which acts as a global booster for all layers, saving you from tweaking each layer's amplitude individually. To keep things optimized, use the start and end fade distance to define exactly where the tessellation kicks in. Pro tip: make sure these values don't exceed your base map distance. Finally, you can adjust the triangle size for mesh density and choose your preferred tessellation mode. Personally, Phong tessellation is my favorite for achieving those ultra smooth organic surfaces. When you are in fidelity mode, you have the flexibility to manage the tessellation factor directly within the Layers tab. This gives you granular control over every single layer. You can decide exactly how much detail each surface needs, and more importantly, you can turn it off for specific layers. If a layer, like smooth sand or flat dirt, doesn't require high detail displacement, simply set its tessellation factor to none. This automatically disables tessellation for that specific layer, saving you valuable rendering power where it isn't needed. Next up is anti-tiling, one of the core features of OptiTerra. To give you the best results, we provide 2 top-tier methods, Hex and the IQ method by Inigo Quiles. Let's look at the Hex method first. This is the most advanced option, where the tiling is completely randomized and broken down with high-quality blending. You can even toggle the UV debug mode to see exactly how the hexagonal grid is working behind the scenes. I highly recommend this method for PC and console platforms, as it's quite intensive for mobile devices. Within the Hex settings, you can adjust how the pattern is generated, allowing you to fine-tune the randomized tiling for each individual cell to achieve a perfectly natural look. Now, let's talk about the IQ method. To be honest, this is my personal favorite. It delivers incredibly precise results with outstanding performance. Unlike the stochastic methods commonly used in other assets, OptiTerra's IQ method has a major advantage. It significantly minimizes shimmering or visual noise at the tile breakups. You can enable the debug mode here as well to see exactly how the algorithm is tiling the surface. In this mode, you have full control over the pattern generation. You can adjust the number of slices and even tweak the hash code to get the exact randomized look you need without sacrificing your frame rate. It's the perfect balance of beauty and efficiency. This brings us back to why fidelity mode is so powerful. In the Layers tab, you can manage these features on a per layer basis, which is where OptiTerra truly stands out from the competition. Often you don't want anti-tiling on everything. For instance, if you have a brick pattern or a specific tiled stone path, you want to keep those repeating lines intentional. With OptiTerra, you don't have to settle for a one-size-fits-all global setting. You can simply uncheck the anti-tiling box for those specific layers, while keeping it active for your grass or dirt. This selective control ensures your terrain looks exactly how you intended, without breaking the patterns that are supposed to stay consistent. Finally, we have the rain effect. Think of this as a powerful bonus feature included with OptiTerra. This tool allows you to simulate how your terrain reacts to wet weather. You can easily adjust the intensity and see exactly how the surfaces become glossy and saturated in real time. You can control everything directly in editor mode and see the changes instantly, making it incredibly easy to dial in the perfect atmosphere without complex scripting. OptiTerra is built with the community in mind, and I am very open to your feedback. Feel free to contact me through Discord and join my server, the same place where I work on my main projects. If you have suggestions for new features or improvements, I'd love to hear them. Join our community and let's make OptiTerra even better together. Before we wrap up, I wanted to show you a direct benchmark comparison. Here you can see the differences between default HDRP, default parallax HDRP, and the OptiTerra shader. Pay close attention to the texture fidelity and how OptiTerra maintains high-end visual detail. But more importantly, look at the render performance. You'll see that OptiTerra offers a superior balance, delivering high-quality depth and anti-tiling without the heavy performance hit you might expect from standard setups. The data speaks for itself. Oh, I almost forgot one more thing. As a powerful bonus included with every Run 2 Go Studio asset, I'm giving you the texture array generator. You can access it by going to the menu R2G OptiTerra Texture Array Generator. A window will appear and you can dock it anywhere in your Unity layout. The usage is incredibly simple. Just drag and drop the textures you want to convert into a texture array, then configure the format settings to match your needs. This tool streamlines your workflow, saving you the headache of manual setup and ensuring your arrays are always optimized and ready to go. Well, that's it for the first look at OptiTerra. I think that covers everything you need to get started for now. If you're feeling a bit overwhelmed or run into any issues, don't worry. Just feel free to ask questions in our Discord community. We're here to help each other build better worlds. Thanks for watching, and I'll see you in the next video.